Here we're going to have a little look at chlorine, bromine and iodine, three of the halogens. So I'm going to show you samples to start with. So we've got chlorine here, so it's a gas, a pale green gas there. We have got bromine here. Okay, so it's quite a reddy, deep red brown liquid there. Okay, so bromine is toxic, so we keep it sealed in our tube there. And we're not going to look at the reactions of the bromine. And then finally, we have got iodine here. So iodine is a silver grey solid there. So I'm going to put some of the iodine solid into a test tube here, and then we're going to heat it carefully and observe what's happening here. Now, can we see very quickly there that we've got purple gas created? If I tip this, we can pour the gas and then we can see it's just solidifying there onto the side of the tube. You get a kind of sparkly grey solid formed there. So as I heated my iodine here, it's gone straight from a solid to a gas. Okay, and that is the process of subliming, so it's sublimation. And you see pouring this gas again. So the gas stays at the bottom of the tube there, meaning it's quite, so it allows us to pour it and us to see what's going on there. So iodine is quite a large molecule, and the mass number of iodine is 127. Iodine has the formula I2, so its molecular mass is going to be 254. So compared with what most of the air is nitrogen, N2, with a formula mass of 28, it's significantly heavier, and so it's got a much greater density there, so it's kind of sinking down to the bottom. We'll now go back to our chlorine, and the first thing we're going to have a look at is how to test for chlorine gas. So in testing for chlorine gas, we need to use litmus paper. So I've got some blue litmus paper and some pink litmus paper here. I'm going to dunk these in at the same time. Now, for our litmus paper to interact with the chlorine gas, we need to be able to dissolve the chlorine gas. So I'm going to damp this with some distilled water first. So watch this carefully as I now put it into the chlorine gas. Okay, so both pieces of paper have now gone white. So our blue paper was originally on the left hand side there. We can see at the bottom there's a little bit of pink there. Our pink litmus paper was over here, and that's still got a bit of pink at the bottom. So to test for the chlorine gas, we are going to use damp blue litmus paper, which will go pink first and then be bleached white. If we use the pink litmus paper, it's just bleached white. But chlorine, it's a non-metal, so it's going to be an acidic gas. So that's why it causes the blue litmus to turn pink first. What we're now going to look at is a couple of reactions of the chlorine. So we're going to have a look at how it reacts with iron wool, and then how it reacts with magnesium. So let me get my next jar of chlorine over here. So what I'm going to need to do here is heat the iron wool up to start with. So here's our iron wool. We'll heat it nice and hot to start with. I'll bring this over so you can see it. And then we will dunk the hot iron wool into the chlorine and observe. I'll twist that round so that you'll be able to see. Okay, so we'll have a few fireworks to start with. So it's just some of the iron burning. Get it nice and hot. see the clouds forming in there? If you look carefully down at the bottom, you can see it falling downwards. There, this is the second sample that I've just dunked in there. So we've got a much more vigorous reaction going on now. So if we have a look up close, so we've got our iron chloride forms where it's caught on the side of the gas jar there. We can just see kind of a patch, but we're going to have iron chloride throughout there. Okay, our second one to try then is magnesium. So I'm going to set fire to magnesium ribbon, and then again we'll just pop that into the chlorine. Okay, so you heard the reaction going on there. So the clouds that form in there are going to be your magnesium chloride forming. In fact, if you look on the end of the tongs where they've gone white, as I was putting the magnesium in, we've got reaction depositing straight onto the tongs there as well.